Right now, 30 million passengers a year walk through a building that is slowly drowning. The airport you're looking at isn't on the coast. It's nearly 5 kilometers out to sea, sitting on an island that didn't exist 40 years ago. An island that should never have been able to hold its own weight. And it's sinking. Not metaphorically. The ground beneath this terminal has dropped more than 38 feet since construction began. And at the moment engineers realized their math was wrong, it was already too late to stop. So they made a different bet. Instead of stopping the sink, they would chase it. Forever. The question that still haunts this place: can a building outrun the sea pulling it under? Stay with me. By the late 1960s, Osaka was suffocating. Its only airport, Itami, was hemmed in by dense city on every side. No room to expand, and residents furious over the scream of jets overhead. Japan's second city needed a 24-hour international gateway, and there was simply nowhere on land to put it. So planners proposed something audacious. Don't find land. Build it. Construct an entire airport on an artificial island, far enough out to sea that planes could roar in around the clock without a single noise complaint. There was just one problem waiting at the bottom of Osaka Bay. The water was over 60 feet deep, and beneath it lay something worse than open ocean. A seabed of soft, alluvial clay, layer upon layer of waterlogged sediment with the structural integrity of wet sponge. Pile millions of tons of rock and soil onto that, and the clay does exactly what you'd fear. It compresses. It oozes. It gives way. The engineers knew this. Their solution was brutal and brilliant. First, they encircled the entire build site with a seawall made of 48,000 concrete blocks anchored by steel chambers weighing hundreds of tons. Then, to force the clay to drain and harden before it bore any real load, they drove 2.2 million vertical sand drains into the seabed, pipes that would let trapped water escape so the ground could consolidate. The plan? The island would sink in a controlled way during construction, settle to a stable height, and then hold steady. Predicted to stay 13 feet above sea level for 50 years. On paper, the numbers worked. Reality had other plans. By 1990, just 3 years into the build, the island had already sunk 27 feet. The forecast had called for 19. They were off by 50%, and they couldn't believe it. The clay was consolidating faster and deeper than every laboratory test had promised, because no test in a lab can fully replicate thousands of tons of fill crushing down across an entire seabed. Worse, beneath the upper clay they'd treated lay a far thicker, deeper layer of Pleistocene clay, too deep to drain, riddled with pockets of sand and impossible to fully predict. That deeper clay would keep compressing for decades. The island wasn't going to settle and stop. It was going to keep going down. And sitting on top of this restless ground was no ordinary building. Architect Renzo Piano had designed a terminal stretching 1.7 kilometers, reputedly the longest airport terminal on Earth, its roof shaped like an airfoil to channel air through the building. Stunning. Also a nightmare to keep level because the island wasn't sinking evenly. Different sections settled at different rates, threatening to twist and warp the structure like a cracker bending until it snaps. Then, on September 4th, 2018, the bay tried to finish the job. Typhoon Jebi slammed in, the most powerful storm to hit Japan in 25 years, packing winds up to 216 kilometers per hour. The seawall had been built to stop a storm surge of 2.7 meters. Jebi sent waves crashing straight over it. Seawater swallowed a runway and flooded Terminal 1. Power died. And then the storm hurled a 2,500-ton tanker into the only bridge connecting the island to the mainland. In an instant, the airport was cut off from the world. Roughly 3,000 passengers stranded overnight in a dark, sweltering terminal, waiting for boats to carry them out. The sinking island had become a trap. Here's where the engineering turns from defense into something almost defiant. The team had accepted a hard truth. They could not stop the sinking. so they built a terminal designed to be raised. Beneath the building stand 900 columns, and each one sits on an adjustable hydraulic jack. As any part of the island sinks, crews jack up the affected columns and slide precision-cut iron plates underneath, lifting that section back to level, plate by plate, fraction by fraction. It is meticulous, relentless work. Manual calibration roughly every 3 years, surveying the entire terminal and correcting it by hand. The airport has poured well over $100 million into fighting the sink, plus another $150 million into reinforcing and raising that overtopped seawall after Jebi. This building doesn't resist the ground. It dances with it. And it's working. The yearly sink rate has collapsed from around